Okay, for this part of the video, or this video, I'm going to go over the first 5 questions on the SLO post test. The first 5 should be pretty quick, so hopefully this video is not too long. It says, which of the following statistics is defined as the 50th percentile? The mean is not the 50th percentile. It can be if our data is symmetric, but if it's not symmetric, it's not the mean. The median is certainly our 50th percentile, so that's actually our answer. The mode is the value that occurs the most. That's not really something we talk about much in this class, so I wouldn't worry about it too much. The interquartile range is how we measure variability if our data is skewed, and the standard deviation is how we measure variability if the data is symmetric. So that takes care of number 1. Number 2. It says a researcher wanted to estimate the average amount of money spent on extracurricular activities per school in the certain region. Researcher randomly selected 20 public schools and 20 private schools in the region to use for a sample, which the following best describes the type of sample that was taken. Well, the census would be taking the entire population, so that's not right. A cluster sample would break up the population into homogeneous groups. That means the groups that are very similar, and then perform some form of randomization to figure out which groups they want to take. So they're going to say have 30 groups and then randomly select 3 and do a sample on the entire group. So that's not what we have here. A convenient sample is something that's bad, something we don't want. It's just taking a sample that would be easy, like me sampling my class when I should be taking a random sample of the whole school. So that's no good. A simple random sample is a sample selected in a way that every sample of the same size has the same opportunity to be selected. Well, I could never have a couple of public schools with private schools, so this is not a simple random sample. This is a stratified random sample where you break the group up into strata, and the strata are oftentimes not the same, and this allows us to make some conclusions or really draw relationships between variables. You can't do cause and effect with a sample, but that's stratified. Number 3. It says that students in a large class measured the time in seconds it took for each of them to perform a task, and they converted them from seconds to minutes. If a student had a standardized z-score of 1.72 before the conversion, the standardized z-score after the conversion should be exactly the same. Converting it is not going to change how far it is away from the mean. Number 4. Now these are the types of questions on number 4 that are they're kind of a pain. You have to read them multiple times, and you have to really think about them. It says a researcher conducting a telephone survey is concerned about the possible sources of bias. Of the following, which is the best example of non-response bias? And this says best example, not just an example. So that's where it becomes more complicated. The first 2 both seem to lead to response bias. In fact, even the third, when you read it, those are all response bias. We're getting a response that's somehow different or misleading from the truth. D and E both seem to be some form of non-response, but we're asking for the best form. People with telephones are overlooked in the sampling procedure. That is true, but how many people don't have telephones? Let's really look at D. It says many of the people selected to participate in the survey who do not respond might have different or opinions different from those who do respond. And that's the big thing. If we exclude people without telephones, is it going to matter? Are they going to respond the same way as the people who had telephones? So this one, it says who do not respond might have different responses or opinions that are different from those who do respond. That's the really important key factor, and that's why it is D and not E. I could understand E, but again, these are one of those tough questions where you really have to think about it. Number 5 says at a large conference of teachers from a variety of subjects, a random sample of 50 mathematics teachers attending a conference was selected. Among the selected mathematics teachers, 28% had taken one or more course in statistics. For which of the following populations is 28% a reasonable estimate of the percentage of people who have taken one or more courses in statistics? Well, this can't apply to all math teachers because not all math teachers attend conferences. I've never gone to a large conference where, well, I probably have, but there are several teachers who haven't gone to large conferences that may not or be represented here. It's definitely not all teachers or all teachers who attend the conference, and it's definitely not all mathematics teachers who have taken one or more courses in statistics because there are 72% who have not. So this one is B. This one is all mathematics teachers who attend the conference. You can only draw it from where your sample was taken. It's just like if I were to take a sample of Sycamore High School students, I can't generalize that to all high school students. I can only generalize it to the Sycamore High School population. So that takes care of 1 through 5. Hope this helps.